All right, what's going on, y'all? Mr. Love here. So today we're going to look at a topic from Calculus BC, finding the second derivative of a parametric equation. This topic seems to get BC students a lot, but it's not that bad if you know the formula and know how to go through the process. So let's take a look at this question. So we have a curve defined by the parametric equations x of t equals cosine of t and y of t equals sine of t. What is the second derivative in terms of t? All right, so first we got to find the first derivative in terms of t. So in parametric world, dy dx, the first derivative is always going to be dy dt divided by dx dt. All right, so this is just essentially y prime of t over x prime of t. So my y prime, my y is sine, the derivative of sine is cosine, so I have cosine of t. And then the derivative of cosine is negative sine. So x prime is negative sine of t. And I'm going to go ahead and reduce this. Cosine over sine is the same thing as cotangent. So this is going to be negative cotangent of t. All right, now when we get to the second derivative, and this is what gets a lot of calc students, the second derivative, d squared y over dx squared, is the derivative with respect to t of the first derivative. So the derivative of what we just got divided by dx dt. So notice this is the same thing pretty much as the first derivative formula, right? So in the first derivative, we took the derivative of y with respect to t and then divided by dx dt. For the second derivative, we're taking the derivative of the first derivative with respect to t and dividing by dx dt. So it's the same formula here, except for instead of the y, we have dy dx. Everything else is the same. All right, so we're going to go ahead and take the derivative of the first derivative with respect to t. So the derivative of cotangent is negative cosecant squared. So I have negative cosecant squared t over dx dt we said was negative sine t. All right, so cleaning this up, the negatives in the numerator will cancel. So I have cosecant squared of t over negative sine of t. And then I'm going to go ahead and just try to write this all in terms of sine, since the answer choices have it all in terms of sine. So cosecant squared is the same thing as 1 over sine squared of t. And then dividing by sine of t is the same thing as multiplying by the reciprocal of sine of t. So this is going to be times negative 1 over sine t. And multiplying across, we get negative 1 over sine cubed of t, which hopefully is an answer choice. I think it is. Yeah, choice C. So the biggest thing to know here with second derivative of parametrics is the formula here. So it's just the derivative of the first derivative divided by dx dt. So